These are the lesson 7.7 notes on solving inequalities using multiplication and division. This is the last set of notes in the chapter and the last set of notes in the unit. The big ideas for solving inequalities using multiplication and division is that we're going to use the multiplication property of inequality and the division property of inequality. You saw these as multiplication property of equalities when we were solving equations. They are exactly the same for inequalities. The multiplication property says that when you multiply each side of an inequality by the same positive number, then the inequality remains true. Next year in Math 7, you will be multiplying by a negative number and seeing that something interesting happens. But for now, we're just going to multiply by positive numbers, and that inequality will stay true. And you can see that with numbers, that if you have 8 is greater than 6, and then you multiply both sides by 2, then you have 16 is greater than 12, and that inequality stays true. And if we look at that with algebra, if we've got x divided by 4 is less than 2, and we multiply both sides of that equation by 4, multiply by 4 because we want the denominator to cancel out. When we multiply, we have x is less than, 2 times 4 is 8, and that would still be true. If we choose any x that is less than 8, like, let's choose 4, so it comes out even. If we put in 4 and do 4 divided by 4, that's 1, and yes, 1 is less than 2. The same thing is true for division. When you divide each side of an inequality by the same positive number, then the inequality remains true, right? So if I have 8 greater than 6 and I divide both sides by 2, 8 divided by 2 is 4, and 6 divided by 2 is 3, and 4 is still greater than 3. That inequality stays true. Algebraically, if I have 4 times some number x, and that's less than 8, then if I want to make the 4s cancel out, I divide by 4, and now I've got 4x divided by 4. That leaves 1x, and 8 divided by 4 is 2, and x is less than 2. This should still be true. Let's check and see. What if I put, let's put 1 in there. 1 is a number that is less than 2. 4 times 1 is 4. Is 4 less than 8? Yes, it is. So that inequality is still true. And then it says that the properties will also be true for less than or equal to and greater than or equal to. You can work the problems exactly the same way. All right, let's do an example with multiplication. I'm going to rewrite this problem just to make it a little bit bigger. I've got x divided by 5 is less than or equal to 2. And I can remember from solving equations that to make the 5 cancel out, if I've divided by 5, I want to multiply by 5. Or mathematically, we talk about multiplying by the reciprocal. So instead of dividing by 5, I'm multiplying by 5. And on the other side, I do that. Then the 5s will cancel out, leaving me with just x is less than or equal to 10. And then it asks me to graph the equation. To graph it, I need to be sure to put on the 0. I need to put on the 10. And then I have to decide, is this an open circle or a closed circle? Because it has that equal sign, that tells me that it is a closed circle. I want all of the numbers, all of the x's that are less than or equal to 10. So I want to include 10, so I make it closed. And then I want all the numbers that are less than that. So I'm going to draw my arrow going back in the less direction. To check, you pick some number from this solution. I need to pick a number that is less than 10. How about 1? 1 is less than 10. So I substitute it back into my original expression. And I can put 1 in for x. Let's see, maybe we'll try it with x is equal to 1. You could pick any number. In fact, you might pick 5 because that would come out to a whole number. It doesn't matter. You can pick anything you want. I'm going to put 1/5 is less than or equal to 2. Is that true? Is 1/5 less than or equal to 2? Yes, that's correct. Deciding whether to show you whether one that doesn't work out. What if you thought, what if you checked x equals, let's pick something that isn't a solution. Like what if you put in 15, all right? And you substitute 15 in for that. 15 over 5 less than or equal to 2. Well, 15 divided by 5 is 3. Is 3 less than or equal to 2? No. You can draw a line through that. No, it's not a solution. It's not a solution because 15 is not on this line. 15 is over here somewhere. Okay? So if you take an answer that is on the line and you substitute it back into your original equation, it should give you a correct statement, should give you a true inequality. If you take an answer and you substitute in and it is not a solution, it tells you that you've made a mistake. You probably have your arrow going the wrong direction. Okay? You have 3 U tries. This one shouldn't give you any problems. You know that means divided by. That's divided, not plus. When you get to 3/5 Q, you need to multiply by the reciprocal. I'll write that down here. Multiply by the reciprocal. So anytime you have a fraction instead of a whole number, then you have to flip it over. So you're going to multiply by 5/3. Right? And then when you get here, be careful because the variable is on the right-hand side. So when you get ready to graph, you want to flip it around, right? Move this on this side and be sure that you flip your inequality symbol as well. All right, let's look at example 2. We have division. I think these are all whole numbers. You have 4n greater than 32. I have 4n means 4 times n. The opposite of multiplying is dividing. So I'm going to divide both sides by 4. You can put the little dot, dot, dot down the middle. The 4 in the numerator and the 4 in the denominator will cancel out. It's like having 1 over 1. So I have 1n left. Greater than 32 divided by 4 is 8. When I graph that, I need the 0. I need that number, 8. You have to decide, is that an open circle or a closed circle? I want all the values for n that are greater than 8. That means that I don't want to include 8. I only want the ones that are greater than 8. I'm going to use an open circle so that I don't include 8. And I want all the numbers that are greater than 8, so it goes to the right. To check my answer, I can pick any number that is greater than 8 and substitute it back into the original inequality. So 4n greater than 32. I can pick any number from over here that I want to. How about 10? That's an easy number to work with. So let's try that for n equals 10. Substitute in 10 for n. 4 times 10 is 40. 40 is greater than 32. So yes, I have a solution. Right? And I don't think there's anything tricky here except being careful when you get to number 6 that before you graph it, that you turn it around and call it 2m is greater than or equal to 50. Right, reverse the whole thing. Okay, and then we have one real life application, which is actually pretty real life. You run into situations like this all the time where you have to decide, is it better to buy like a season pass or is it better to pay as you go? So in this case, we're talking about a bus ride. A one-way bus ride costs $1.75. The 30-day pass costs $42. And you have to decide at what point is it a better deal to buy the bus pass, and at what point is it better to pay as you go. And there are all kinds of situations like that, like going to the Santa Cruz Beach Boardwalk. Are you going to buy that season pass, or are you just going to go once or twice? Or maybe it's a zoo membership or an aquarium membership. Many things are set up like that where you get a discount if you go a whole bunch of times, but if you only go once, then the discount doesn't pay off. It costs more. So let's find out. We're going to write and solve an inequality to find the least number of one-way rides you must take for the 30-day pass to be a better deal. This word least could be a little misleading in this because I think what I'm trying to find out is this. I want the 30-day pass to be a better deal. I want for this to cost less than this. All right. So let's flip that around. So I'm going to say the one-way bus pass so that maybe I need the number of. Okay, so the number of one-way bus passes times $1.75. That has to be more than $42. Right, that seems a little backwards, so let's kind of talk through that. Right. If the amount that you are spending pay as you go is greater than $42, then it is cheaper to buy the bus pass. Does that make sense? All right, so let's change that into an inequality. So this is the variable, the number of one-way passes, and it doesn't tell you what to use, so we can use n. And we're going to multiply by $1.75. I always like to put my coefficient in front of the variable. And that's going to be greater than 42. And then to isolate that variable or get the n by itself, it's okay that it's a decimal. Still divide by $1.75. Whatever you do to one side, you have to do to the other. And you could do that division, but you can also use your calculator and take 42. Let's do it together. You can do 42. Why is that not showing up? There it is. 42 divided by $1.75 equals 24. So when n is greater than 24, so when you are buying more than 24 tickets, the pass is cheaper. All right. So 24 is the breaking point, right? If I take $1.75 times 24, I get 42. So at $42, they cost the same. And then, or at $42 or 24 tickets, they cost the same. But if I'm buying more than 24, then it makes sense to go ahead and buy the bus pass because that will save me money. It says you ride the bus an average of 20 times each month. Is the bus pass a better deal? Well, no. It is cheaper to pay $1.75 each time. And we could even check that and do the math. We could take 20 passes or 20 bus rides times $1.75. And let's see. I feel like I should do that on my head, huh? $1.75 times 20. Oops, you can't see that. There it is. Equals 35. So this costs $35 and the bus pass costs $42. So we want to pay as we go. All right. All right, and then you have a similar you try. This time we have the toll is $2.50 for a car. This is the toll for driving on Alligator Alley. Write and solve an inequality that represents the number of times someone can drive on Alligator Alley with $15. Okay, you can't spend any more than that. You can spend up to 15.